नमस्ते दोस्तों, मैं आप आज लोगों को इक्विवेलेंट रेजिस्टेंस टर्मिनल्स ए एंड बी का कैसे फाइंड आउट करेंगे उसको मैं बताऊंगा। फर्स्ट ऑफ ऑल वी हैव गिवन दिस सर्किट एंड वी हैव टू फाइंड आउट द इक्विवेलेंट रेजिस्टेंस अक्रॉस द टर्मिनल्स ए एंड बी। So before starting or before solving the questions, I would like to say something to you. First of all, we know that in electrical engineering, same potential is equal to the same point. Yes or no? Same potential is equal to same point. So हम लोग देख सकते हैं यहाँ पे A and B दो पॉइंट दिया गया हुआ है। हम लोग को फाइंड आउट करना है R equivalent is equal to how much. So already I have told you that in electrical engineering same potential is equal to same point. So यहाँ पे from here this is the B. We can write here because not a single electrical elements is present between these 2 points. So we can write here B. We can write here B, and we can see here from here to there not a single electrical elements is present. So the point will be similar. Here we have written B, so this point will be also B. But coming to this point A, we cannot write here A. We cannot write here. Why? Because the electrical elements, the another resistance R1 is present. So the point will be different. So already we have the A and B. So we can write here the C. We can write here C. Yes or no? Because the another electrical elements is present between these 2 points. That is the R1. So the points will vary. So it will be C. It will be C. Yes or no? So we got 3 points A, B and C. Now let us try to solve the complex circuit into the normal form. How can we solve? Let us try. So first of all we have the 3 points. Let us draw first point, second point and the third points. We have the A, this is the B, already we have. Another point that we have that is the C. Let us write here C. So we have 3 points. Now see the between the B and C. We have the B and C. There is the B and C. There is the B and C. There is the B and C. We have the resistances between B and C. We have the one resistance, that is the R2. Yes or no? We have the R2 resistance is there. So we have to write R2 here. Again we see here B to C, and the resistance is there, that is the R3. Yes or no? R3 is there. Yes or no? R3. Now you see here between B and C R4 is present. R4. This is the R4. Yes or no? This is the R4. This is the R3. Yes or no? So and between the A and C we have the resistance, that is the R1. We have the resistance, that is the R1. Now we can solve here. This is the point B. Yes or no? This is the point B. Now we can see the R2, R3 and R4 all are in the parallel, and the R1 is series 2 with this one. So we have to solve this one. How can we solve? So we have to find out the R equivalent from the A to B. Yes or no? From the A to B. Now how can we solve the equivalent resistance of R and A to B? Because the 3 R2, R3 and R4 in parallel, and R1 is series to this one. So we have to find out the R equivalent of AB. Yes or no? AB. So R1 is parallel to this one. Yes or no? R1 plus of this one. Yes or no? Because R2, R3 and R4 in parallel. So we have the formula. We can write here 1 by R2 plus of 1 by R3 plus of 1 by R4. Yes or no? This is the one formula we have. How can we write this one? Because we have to solve this 3 1. Means R1 plus of how much? This will be R2, R3, R4. We have taken the LCM here. Means R2 it will be the R3, R4 plus of R2, R4 plus of R2, R3. Yes or no? So R1 plus of this one, it will go up when you're solving the parallel. So R2 R3 R4 divided by R3 R4 plus of R3 R4 plus of R2 R4 plus of R2 R3. So we got the R equivalent of total equivalent resistance is equal to this one. So this is the way, one of the way to solve the equivalent resistance of the complex circuit. So whenever we have the given the value of the R1 R2 R3 and R4, simply we'll keep in this formula, we'll get the answer. Thank you.